One area of improvement in simulation is with how to deal with problems when we have mesh problems. Let's just create a quick study and show an example of that. So when we create a mesh, we're just going to force it to cause a failure. What's going to happen is we've put a lot more intelligence in how to resolve the problems. We have a mesh diagnosis tool which gives us a few options in terms of how we can deal with the problem. In this instance, for example, the knuckle here, which is this component over here, doesn't mesh, and so we need to find a way of addressing that. There's a few options from putting incompatible meshing in there so the elements don't have to match up at the boundaries, to putting mesh controls to get a more refined mesh in a given area. So if we click on mesh failure, it brings up the simulation advisor. So if we select the faces, you can see it actually highlights the interface faces here that are having the problem. So we can address that. If we select the knuckle, we can come in here and say, do a mesh control. And this is the new option here, which is this create mesh. What that will do is it only creates a mesh for the failed part. Everything we've already done is going to be preserved, and we're just going to mesh the failed components. So it's a huge time saver, especially in more complex models, to help you out in getting your job done quicker. And just like that, we have our finished model all connected up. So that's a great time saver for helping it resolve mesh problems. Let's look at simulation performance improvements, because this is another area we've spent some time. And the key one here comes in meshing as well, where we're taking advantage now more than we have in the past for supporting multiple cores in a computer. It really is tailored to situations where you've got more than one component in a model. So if you've got large numbers of bodies, then we can really take advantage of multi-cores to go through and mesh all those components. You can see in here, with 4 cores in your computer, you can get quite a significant reduction in the time it takes to mesh the system. This is averaged over a variety of test models, so it's not just one particular case. Also, in terms of for nonlinear analysis, they've made some improvements in the ways we're representing the models. So they've reduced the number of equations, which in turn has helped reduce the solve time for those models. This is some preliminary testing. If we get more detail, we'll add that at a later stage. But at this stage, we're seeing about a 20% reduction in solve times for nonlinear models. Let's take a look at some other improvements in the meshing robustness. Here we have the full suspension assembly model with that knuckle in turn. And what we'll find is that by default with the curvature-based meshing, we've got some really improvements in the robustness. So there's nothing special about this, it's just setting the curvature-based meshing as our option. We'll see it goes through now and does an incredible job of meshing this model, not only very quickly, but very robustly. So you'll find in 2011 that the meshing robustness has improved, and putting that in conjunction with our mesh diagnosis tools, we should find a lot more or less pain in doing meshing now than you have in the past. So look at that, it just, with very little effort, not even having to put any mesh controls in, it's come in and meshed the geometry from very small things such as this washer and nut, all the way through to the spline on the shaft. It's incredible that you can do that now without having to do anything. It really shows how good the SolidWorks simulation mesher has become. So that's some of the improvements on the simulation front to help you out with meshing.